So we're going to talk about log equations with the same base. All right, so there's two different scenarios. Our first scenario is when our log is equal to some number, not a log. So we want to make sure all logs have the same base. Then once you make sure that all the logs have the same base, what we want to do is condense to one log. We want to isolate just the log with its argument. Then we're going to rewrite the equation as exponential. If you guys remember, it's log, base, answer equals exponent. We are going to solve the equation and we will have to check our answers. And really what we're checking for is we can't have a negative argument. Okay, so that is the first scenario. Let's talk about our second scenario. This is when log is equal to another log. So once again, we're going to make sure logs have the same base. We are going to condense left and right side to one log. Then we are going to set our arguments equal. And then we are going to check answer. And I'm going to put a star. Once again, arguments cannot be negative. Are we ready? Okay, so let's do some sample problems. Okay, let's say I have log base 2 of x plus log base 2 of 4 equals 5. Okay, so which scenario is this? Is this our first case where log equals a number or where log equals another log? It is our first scenario where log equals a number. So what do we have to do? According to our steps, is we have to condense the left side. First we check, do they have the same base? Yes. Since they have the same base, I can now condense it down to 1 log. How do I condense this down to 1 log? Log addition becomes 1 log with what? Between their arguments, with multiplication between their arguments. So this is going to be log base 2 of x times 4 equals 5. Well, do we agree x times 4 is 4x? So we're going to have log base 2 of 4x is equal to 5. Now we're going to go back. So what does it say? Go back to your steps. Condense to 1 log. We did that. Rewrite the equation as an exponent. So that's our next step. We're going to rewrite the equation as an exponent. So remember, log base, our argument is our answer, equals our exponent. So now if we're going to change this back into exponential, what is the base? 2. So that's my base. What is my exponent? 5. That's going to equal the answer. What's the answer? 4x. Now we solve this. What's 2 to the 5th power? 32 equals 4x. Can I solve for x? Absolutely. I'm just going to divide by 4, and we will get x is equal to 8. Right. I need to check my answer. Essentially, all you're checking for is that by me having x equals 8, it doesn't make any of my arguments negative. 2 to the x, if x is 8 and a negative argument, no. 2 to the 4, to whatever, we're good. No negative argument, so my answer is good to go. Okay, next one. Two times the ln of x is equal to the ln of 25. well, actually, let's not do, it's not that bad. Do we all agree that ln is log base e? Yeah. So if it makes you feel better, you could do log base e of x equals log base e of 25. So is this log equals number, or is this log equals exponent? Oop, I put log base too. This is log equals log. All right, so when it's log equals log, what we want to do is condense them both to one log. First, we make sure, do they have the same base? Do they have the same base? Yes. This is already condensed to one log, and this is pretty much condensed to one log, except there's something I can simplify here. Does anybody know what I can do here? I can bring that 2 up as an exponent. So I'm going to bring that 2 up as an exponent, so this is going to be log base e of x squared equals log base e of 25. Now that we got it, where there's nothing else except the log and its argument, we did that, right? Log, argument, log, argument. Now, because they have the same base, we can set their arguments equal. So now I can say x squared equals 25. Can we solve this? We sure can. To undo a square, we take the square root. What's the square root of 25? Only 5? Plus or minus 5. But can an argument ever be negative? No, and isn't this saying log base e of x? Well, can x be negative 5? Is that possible? No. So we're going to reject the negative. So x will just equal 5. Yes, Nico?
So when you say condense left and right side into one log, you don't mean combine both sides into one?
No, one log on the left, one log on the right.
You're just saying like simplify them basically?
Yep, that's it. Okay, next one. Yes?
Get my water bottle real quick.
Sure. Okay. So is this log equals log or log equals number? This is log equals number. So what do we want to do? On the left side, we want to condense it down to one log. First, before we're allowed to condense it down to one log, what do we have to make sure of? Both logs have what? Same base. Do they have the same base? Yeah. So now I'm going to condense it down to one log. Where am I going to start? Well, I'm going to start with this 2 becomes what? An exponent. So this is log base 3 of the quantity of x minus 2 squared minus log base 3 of x minus 4. I'm still not done. I need it down to one log. But because they have the same base and it's log subtraction, what can I change that log subtraction into? One log with division between them. So this is going to be log base 3 of x minus 2 quantity squared over x minus 4 equals 2. This is my argument. Your goal always is to get the log down to one log, one base, one argument, nothing else with it. Have we done that? One log, one base, one argument, nothing else with it. Yeah. Now that I have that, it's log equals number. So now we change it back into exponential. Remember, log, base, answer equals exponent. So now when I change this back into exponential, my base is not Nico, somebody else. My base is what? 3. Good. My exponent is 2. And my answer is the whole entire argument. X minus 2, that quantity squared, over x minus 4. All right, let's keep going now. So now we're going to have 3 squared, which is 9, equals x minus 2 squared over x minus 4. We're going to have to solve for x. So what I'm going to do is I'm going to cross multiply. And when I cross multiply, I'm going to get x minus 2, that quantity squared, times 1. Do I really need to do that times 1? No, 1 doesn't change anything. Equals 9 times the quantity of x minus 4. Is it important that I put that x minus 4 in parentheses? Yeah, because I'm going to have to distribute that 9. So when I distribute that 9, I get 9x minus 36. What do I have to do with that x minus 2 quantity squared? Any guesses on what I have to do there? I think I heard it. Foil it, exactly. When we foil it, this is going to be x minus 2 times x minus 2. Matt, could we take our AirPods out, please? So now we're foiling. X times x is x squared. X times negative 2 is a negative 2x. Negative 2 times x is a negative 2x. Negative 2 times negative 2 is a positive 4. Combine our like terms here. We get x squared minus 4x plus 4 equals 9x minus 36. I am going to have to factor. In order to factor, I need to set it equal to 0. So I'm going to subtract the 9x on both sides, and I'm also going to add the positive 36 to both sides. And when I do that, I get x squared minus 13x plus 40 equals 0. If I'm going too fast, just tell me to slow down. So now we factor. So I have an x and an x in front. And then I need two numbers that multiply to positive 40, but add to a negative 13. Does that make sense? You got it. Negative 5 and a negative 8. So it's x minus 8, x minus 5. Are these my answers?
Well, yeah.
Not yet. What do I have to do? Set them equal to 0 and solve. So x minus 8 equals 0, x minus 5 equals 0, x equals 8, x equals 5. I will tell you neither of these make the argument negative, so we are able to stop here. We have two answers for x. All right, you guys try this one on your own. I'm going to give you two to try on your own. What number was this? 3? Who wants more time? Okay. What's wrong? You good? Oh, that's a 12x. What happened? Oh, you're looking at, I'm looking at number 3. Never mind. Log base 4. So then oh, x times x is x squared, not 2x. There you go. Guys, x times x is x squared. X times x is x squared. So we look at what it equals. So this one? This one. Okay. So see how it's a log on the left side and a log on the right side? So that's the case 2. Log equals log. Log on the left and log on the right. In case 1, it's just logs on the left but no logs on the right. So this is going to be case 2. So what you want to do is on both sides condense it down to just 1 log by using our rules. So showing. Okay, that's fine. Anybody need my help? Mm-hmm. Hey, how are you doing? You're good so far. 2 to the 5th power is a 25, right? 2 to the 5th power is 32. That's probably why you this side first. So that's log subtraction. What can we change log subtraction into 1 log with what between them? The arguments. Division. So you're going to have a log, 1 log. 12x, right? First argument divided by the second argument equals 1 again. And can you simplify this? 12x divided by 4. So now that you've got them both down to 1 log, and they have the same base, you're just going to set the arguments equal to each other. Yeah. Try the next one. Stefanos, you good? Yeah. Alright guys, let's go over at least the first one now. So for the first one, which scenario is this? Is this case 1 where log equals a number, or case 2 where log equals a log? Second one, where logs equals a log. Log on left side, logs on the right side. So what you want to do on the left side of the equal side, condense it down to 1 log. On the right side of the equal sign, condense it down to 1 log. On the right side, we are already condensed down to 1 log, so there's no work we need to do on the right side. But on the left side, I have 2 logs. You want to make sure they are the same base. Do they have the same base? Yes. If they do not have the same base, can I condense them? No. But because they have the same base, I can condense it. So I'm going to pull 1 log out, and then what can I do with their arguments? Since it's subtraction, I can divide them. Once you get it down to 1 log and 1 argument on both sides, and they have the same base, now I can just set the arguments equal. So I have 12x over 4 equals 15. But what's 12x divided by 4? 3x equals 15, so x will equal 5. How many people got that? Perfect. Who needs another minute for number 5? We're ready for this? All right, so this is where the log equals a number. So this is our first case scenario. In the first case scenario, on the left side where there's multiple logs, you make sure they have the same base. Do they have the same base? Yes. Since they have the same base, can I condense it down to 1 log? Absolutely. So I'm going to pull out 1 log base 2, and then I can multiply their argument. I need a parenthesis around the x plus 4 because I'm going to distribute in. Now that's going to equal 5. So now that I have it down to 1 base, 1 log, 1 base, 1 argument equals a number, now I'm going to change it back into exponential. When I change it back into exponential, I'm going to have 2 to what power? The 5th power is equal to the argument, which is x times the quantity of x plus 4. What do I have to do with that x times the quantity of x plus 4? Distribute in. So 2 to the 5th power is 32, and that's going to equal x squared plus 4x. I'm going to have to factor, so I'm subtracting that 32. So we get 0 is equal to x squared plus 4x minus 32. And then we factor. Give me 2 numbers that multiply to a negative 32 but add to a positive 4. Negative 4 and a positive 8. Are these my answers? No. We now just have to set them equal to 0 and solve. X minus 4 equals 0. X plus 8 equals 0. So x will equal 4 and x will equal negative 8. Do both of these answers work, or does one of them get rejected? Which one gets rejected? The negative 8, because we cannot have a negative argument. So x is just 4. All right, so there's one more thing I need to show you. So I kept saying, make sure they have the same base, make sure they have the same base, make sure they have the same base. What do we do if they don't have the same base? That's what I'm going to show you now. Log equals number, different bases. So all we're going to do is keep changing to exponential. And then I'm going to say the argument is always what's in the parentheses. Okay, so why did I make that extra note? The argument is always what's in the parentheses. Because I have 2 logs here, and they have different bases, there's no condensing for me. There's no changing it down to 1 log because they have different bases. So this means I have to keep changing it into exponential. Well, this is my base, and what did I say? The argument's always what's in parentheses. So this is my argument. And that means this is my exponent, right? Log, base, argument, exponent. All right, so when we go back into exponential, my base is 5. What's my exponent? 0. And what should that equal? Well, on the other side. So it's log, base, exponent equals the argument, which is the answer, right? So 5 raised to the 0 power equals log base 2 of x. Well, what you guys told me, what's 5 to the 0 power? 1. So 1 is equal to log base 2 of x. What am I going to do again? exponential again. So remember, base, what's in the parentheses is my argument. This is my exponent. All right, so what's my base here? 2. What's my exponent? And what should that equal?
X.
The argument, which is the answer. So that should equal x. What's 2 to the first power? 2. So x is equal to 2. We solved it. Let me give you another one. You guys try this one. Ion? You guys want me to go back up so you can see?
So we're going to change it into exponential. What's your base? So let's do that. No. Like we're writing it as exponential. Erase that. Don't write log 3. So just write the base by itself. So 3 raised to what power? Equals the argument, which is, yeah? Okay, so what's 3 to the 0 power? Not 0.
Oh,
1. So now write 1 equals log base 5 of x. Okay, now we're going to change it back into exponential again. This time, what's your base? So put 5. It doesn't matter. Oh, no, sorry. We're putting it back into exponential, so it's not multiples. So we're just going to write 5 raised to what power? Not 0. 1, right? Because it's log base argument equals exponent. Okay, equals the argument, which is x. And what's 5 to the first power? 5. So x equals 5. We're done.
All right, guys, so for this one, we keep changing it into exponential. First, my base is 3, my exponent is 0, and that equals my argument, which is log base 5 of x. 3 to the 0 power is 1. And now we change it into exponential again. So this is 5 to the first power equals x. Well, 5 to the first power is just 5, so x is equal to 5. How many people got that? Okay, I'm going to step it up just a little bit. We're going to do 2 more problems and then we'll be done. Log base 7 of log base 3 of log base 2 of x. What did I say was the argument?
Parentheses.
What's in the parentheses? So this whole thing is my argument. Whatever's in the parentheses is my argument. Do they have the same base? No. Since they do not have the same base, do I even try condensing it down to 1 log? No, never when they have different bases. So now my only choice is to keep changing it into what? exponential and trying to solve. So to start, what's my first base going to be? 7. What's the exponent? 0. Good. And what's that going to equal? On the other side. The whole entire argument, which is log base 3 of log base 2 of x. Now I simplify down. 7 to the 0 power is 1. And what did I say was always in the parenthesis? The parenthesis is always what? The argument. What's in the parentheses is always the argument. So now I need to change to exponential once again. What's my base this time? 3. What's my exponent this time? 1. And that's going to equal my argument, which is what? Log base 2 of x. I'm not done yet. Are we still good though? Everybody following along? What's 3 to the first power? 3. But now I have one last time to change it. So this time my base is not 7, it's not 3. This time the base is 2 raised to what power? 3 equals x. You got it. So x is equal to 2 to the third, which is 8. All right, should we stop? We done? Okay, we're done for today.